Russ. Thank you. Hi, everyone. Thank you for joining us today, and thank you to Russ for the introduction. I'm looking forward to what I'm sure will be an incredibly insightful discussion between the three thought leaders that we have with us on the virtual stage here today. The format of the session will have three presentations from each of our panelists. We'll then open into a discussion, and following this, we'll have a 45-minute Q&A session. So do submit your questions as we go. Now, Dev is going to take it away and tell us a little bit more about how we can fuel the growth of smart cities through AI.
Thanks, Emily, and it's good to be at CogX again. I think this is my third year in a row, and obviously the first for everyone to be virtual. That said, if we could share a couple of the pretty slides that I'd like to share with the rest of the audience today, and I'm going to hopefully that's streaming now. Okay, so I'm going to talk a little bit about what we do at nPlan, but specifically try and wrap that around the concept of the built environment and how it's how technology is can be an enabling force to closing the $1 trillion gap. So what is the $1 trillion gap? The $1 trillion gap is known as the amount of capital required to fund the critical infrastructure that we require as society to make sure that we continue to prosper. It's not a big surprise that we need more infrastructure than we have money available, and that delivering infrastructure or doing construction projects, quite simply, is a really tough job. And it's so tough that most of the construction projects we know about have simply not been done very well. They've been grossly over budget and grossly overspent. And there's some really good examples of that. I know CogX this year is virtual, which means we have people coming in from all around the world, but I live in London, and as a Londoner, I'm eagerly awaiting the starting of our new underground railway line, which is also known as Crossrail. Crossrail is, alongside the Millennium Dome and Boston's Big Dig and Sydney Opera House, one of those challenging projects. Yes, it did not overrun by 1,300% like the Sydney Opera House, but it is significantly over what the original forecasts were. And this begs the question, like, why does this happen? Why is it so hard to deliver these construction projects on time? And why is it that these failures have led to a tremendous gap in the funding environment that we have for our cities and infrastructure needs as a world? I'm going to show you the answer in one slide, and this is it. This is a plan, which may sound a little obvious, but a plan or a Gantt chart is how we estimate how long a construction project might take. What I'm showing you on the screen is a really simple project. There's probably like 100 or 120 activities on here. I mentioned Crossrail, London's underground rail line earlier, and its Gantt chart has over 1.1 million activities on it. So just imagine this sheet at an exponentially longer and more complex function. And this was created using people. So people like you and I sat in a room and decided that this is how long each activity should take. And so when you come to think of it, it's not a big surprise that these activities aren't perfectly planned, which means you have a cascading effect, as it shows here. It's like a little waterfall that would result in whatever happens towards the end is probably not going to be on time. And the tendency is that we as optimistic beings end up overestimating our ability to deliver things on time. And so projects are mostly late. And because these projects are perpetually late, means that it's awfully complex for someone to fund it. And when I say someone, I mean governments or institutional investors to fund such projects, which is why we have the $1 trillion gap. And that gap is becoming increasingly large with time. For context, we as a planet spend roughly $6 trillion every year building stuff, and that's expected to grow to about $12 trillion by 2030. So we need a solution. And this is where the opportunity in machine learning kicks in. What we've done at nPlan is we've learned how hundreds of thousands of those ugly plans or Gantt charts performed in the past. And then our machine learning system uses that knowledge to be able to forecast how long a project is probably going to take. So in effect, you take data from past projects and use that to predict the next project of current and future projects. And this technology is especially powerful because we're using it on live projects today, like High Speed 2, and we did work on Crossrail for a little while, to be able to help the project team use the power of data to forecast their projects. And these systems are effectively, they effectively remove human bias in the planning process, which is the human bias towards eternal optimism. And it gives people a realistic sense of what might happen along the course of a mega project, which could be 5, 6, or even 10 years of work to get to that endpoint. We do all of this using an online system. I did say that that we put a lot of data into the system to sort of feed the algorithm. I'm sure most of you know that machine learning systems are only as good as the data that they're presented with. And in our case, that is especially true in our case as well. And we've now processed just over $850 billion in construction projects, which is by far the largest volume of construction projects anywhere in the world. For scale, $850 billion is 4.5 times the entire construction economy, construction industry in the UK. So needless to say, nPlan operates at a global scale already. We create lots of nice visuals that help consumers use this information, but I want to focus a lot more on what happens as a result of all of this. So it's cool that now there's a machine learning system that can tell you how long your project's going to take, right? So I hope I'm allowed to say these words. We can cut the bullshit from how long a project is probably going to take. And I'm sure a few of you that live in the UK have seen the headlines around High Speed 2. And we work on High Speed 2 now. So hopefully in a news headline coming up soon, you'll actually see how long the project will take and how long it actually will cost. But I talked to you on the first slide about the $1 trillion gap. How do we close it? And the way we do this is by quantifying the risk of a project on the upfront, which is what we do today, using that knowledge to help the contracting parties, so this is the person buying construction, the person delivering construction, come to an agreement on what's the most realistic outcome. And then use that to set contracts. Now, contracts being set can apply, and usually always apply, to the financial investment that is required to institutionalize the investment. This is, how do you convince, let's say it's the government that is funding a project, how do you convince the government that taxpayers' money will actually be able to deliver on the asset? The way you do it is by quantifying the likelihood of that delivery. And then it becomes a weighted assessment on the value of the investment going in. And we see this today. nPlan is already working with insurance businesses where we can underwrite the outcome of a construction project, as well as with a few very large pension funds and institutional investors where we can help them quantify their investment risk, which, this is the exciting part, and I'll jump to this final QR code. So if you have a phone, you can take your phone out and take a photo of that QR code, and it'll take you to this article that I wrote a couple of months ago about this topic. And what we're essentially enabling now is the systematic transaction of risk. And the systematic transaction of risk, which sounds like a big, ugly mouthful, essentially means you allow more investors to come onto the table to help close down that gap, which is what we need if we want to be able to fund the projects that are going to drive our economy. These are the exciting projects that are connecting cities from one to the other. These are the exciting cities that bring in clean energy and clean water to the people that need it the most. And we absolutely need a systematic method to get to that point. I'll leave you in the last couple of slides, last minute, with a little anecdotal bit, which is that no machine learning system is built by itself, even though we contain the word AI as a grand old term. It's built with the most intelligent people in the world. And these are some of the people that helped build the nPlan system to what it is today. This is a slightly dated photograph. This photograph was taken over a year ago now at Hinkley Point C, which is the largest construction site in Europe currently. But it takes mathematicians, it takes neurosurgeons, it takes machine learning engineers, software engineers, aerospace engineers. It takes people with art degrees. It takes people with all walks of backgrounds and lives to be able to influence and help design systems that have never been built before, and push the boundaries on what is technically possible, and then what is financially possible, which is where you start to see the world change its perspective. And once again, I'm Dev. I'm the co-founder and CEO of nPlan. That second QR code is to my LinkedIn profile. If you want to take a photograph of it or send me an email, I'd be happy to follow up with questions afterwards. But I'm also sticking around for some Q&A with that. And I think I hand over to Heba, if I didn't ruin that one, who also worked on Crossrail and helped out a ton there. So I'll hand it over to Emily, who I think will hand it to Heba.
Thank you very much, Dev. Yes, that was brilliant. We'll hand over to Heba now, who's going to tell us a little bit more about how AI can improve infrastructure projects in the UK and throughout the world.
Hello, good afternoon, everybody. My name is Heba Bevan. I'm the CEO and founder for Utterberry Limited. I don't know if you can see my screen fully and my presentation. So Utterberry is founded back in 2013. We spun out of Cambridge University. It's a patented technology, and we're very proud to be the first sensor network that provide an edge computing. What does it mean? Our sensors actually have an AI and machine learning system within the sensors. We deployed this technology first in tunnels, so in London Underground tunnels, and we worked on 8 major stations within the Crossrail. And then we moved out to Network Rail, various projects. We won various awards around these on that line. We got the Best Innovation Award for Crossrail. And we, in 2016, we looked at infrastructure as a whole. It's not just how can we make our building smarter, bridges smarter, how can we actually provide a smarter way in living, in a medical sense, in a sport, in agriculture, and in our infrastructure. So just to give you an idea, we are an approved supplier for the Crown Commercial Service. We have major patents, and all our patents to deal with how can we manufacture the sensors, the AI and the machine learning of the sensors, the medical devices as well, the blockchain technology for security around it, and how can we actually expand in this global smart sensor market, which is expected to reach around $60 billion by 2022. So the company we design as well an infrastructure for AI that sits on the edge of the sensors, where it provides us our neural network, and every sensors communicate to other sensors, and from there to our base station, then to our cloud. So we have 3 compartmental kind of AI and machine learning. We won major projects in Crossrail and Tideway, which is the biggest sewer in the UK. As well, we are very heavily involved in one of our partners is Cisco on that. We work on the architecture of the hardware that is currently based on silicon, and we are investigating compound semiconductor, which is a new exciting things. We manufacture all our products in UK, so our hardware and software completely is done in the UK, and our headquarter is based in London. And just to give you an idea, and actually, what do we actually measure? So if we take a bridge and we Utterberize it, so what that gives us, it gives us the number of pedestrians, number of cars on the bridge, their loading on this bridge, what that swing from the temperature and humidity that is acting and effect on the bridge, while these changes, the temperature, the humidity as well, the tidal levels, if vessels coming in, the opening and closing of these bridges, and as well, it gives us another communications in terms of the lighting system within the bridge, if there is nearby underground going on, and how can we actually interact with different infrastructure. So our capability to communicate with other Utterberry's building nearby, and this is give us a sense of communication into the smart. And just to give you an idea in here, we have a model of Tower Bridge. We monitor Tower Bridge for over 5 years, and currently there is an big tunnel with sewer called Tideway. Tunnel is built underneath it. So all our data is a real time, and it gives you as well full prediction on the system, what's happening. So as my colleague is pressing on the bridge, you can see these elements, and it is in real time, and it gives you full actually AI on top and a prediction what's happening with the structure. So here is Moorgate Station. So as I said, we worked on 8 major stations within the UK. Just to give you perspective on how much it costs today to close one station. To close one station, it costs London Underground £11 million per week. So if you multiply £11 million by 52 weeks, which is a year, it costs over £500 million on cost for our current network to shut down these infrastructure. So we haven't all, when we operate these systems and these stations, we expect these stations do not close. And we did that with Moorgate, Liverpool Street, Blackfriars, Farringdon, Barbican. So these stations, it kept open to the public, and the transport continued while the construction happened underneath it. The same here with Tideway. So these are bridges and tunnels. We need to make sure they are absolutely open all the time. So the fixture, well, how do we fix the sensors to these infrastructure? You can see here is Tower Bridge, and we fix the sensor by using either adhesive or magnet or screwing the sensors. So here we've used adhesive on the Tower Bridge, and the type of adhesive we've used that it would not even peel the paint. So we made sure it will keep the structure integrity of it. The way when removing the sensor, we leave it exactly in the same way. Other things, we are currently working on a 5G with the Welsh government, and as I said, one of our partners is Cisco, and one of other partners is Abipay. So these, what we're doing in here, designing a sensor system that is communicate through 5G, and working on rural areas and a transport. And some of these areas, which is we're working on, the network within these areas is really, really minimal. So how can we get an ambulance on time to some of these villages? Or how can we provide a better remote system in terms of transport to them? So all these is work within our infrastructure and what we currently working on. One other things what we've done in a Crossrail is counting people in and out. With applying into, and we stick very, very closely with GDPR, So ours is not camera. So we have our own technology. While the sensor, it measures the tunnel wall movement, temperature, humidity, and water leak, we actually as well measure the number of people in and out of these zones. This is enabled the Crossrail to have a trigger when there is an alert or a fire or an emergency. How can we get the people out as soon as possible? Which exit it's safe to exit? And if this is your closest door or closest exit, maybe that is not the safest one. So we provided them with a whole metrics and of sensors that is zoning the people where they are and where can they and how can they escape if there is an emergency. So as you can see, the way we view the people, we view them, we cluster them by red and green. And this actually technology is currently as well used in universities for COVID, to clustering people, how they are not in a closer proximity. We worked with ECB, England Cricket Board Association, on their human interaction and how can we maximize the athletes and the uses of a station. So you can see one of my colleagues here where we worked on the elbows, how much it is, what the rotation of the ball, and we measured our system compared to Hawkeye, and we came hugely 100% accuracy on terms of installing this system. We worked very closely as well with Ascot, the royal enclosure for the Queen, and for whole entire year, and to provide a platform to measure the full stadium. How can the platform handle the number of people on it and the interaction between the doors opening, close, the people on these platform, the finite element analysis within this to give us the structural integrity of it. And you can see in here when the Queens arrived, and was one of the days of racing, that is number of people went into red, which is quite critical. So how can we minimize that number into this, and how can we manage these stadiums while the quantity of people is going in? One other things as well, we've been working currently on a new patent device for COVID. This is counting people in and out, have biometrics capability, accurate imaging and screening, and sound detection, and NFC, RFID. And here what you can see, it's how can you check in people in and out in an accurately way. This is being deployed right now for 4 different schools within the UK, trialing this system on their staff, and how can they provide a safer way to go back to work. So our as well technology, not just in the UK, we work internationally. We've been working on Singapore area, Hong Kong, Australia, and US, and it would be lovely to work with you all. Probably I hand it on to John, the CTO for Cisco, and thank you very much for listening to me.
Thank you very much, Heba. That takes us nicely on to John's presentation about wireless and AI and how it can help us become smart city ready. Hand over to you, John.
Thank you, Emily. And thank you also, everybody from CogX team for inviting me to participate. This is my first time participating, so I'm quite excited. And can you please share my slides? Here, go full screen too. Great. So today I'm going to talk about emerging opportunities in smart cities through wireless and AI innovations. Now, whenever we talk about wireless, it's important to consider the spectrum, because you need spectrum to actually have wireless. And there's some massive changes occur now in spectrum, and I want to just highlight a few of these for you. First of all, we all use Wi-Fi. So let's see what's happening in Wi-Fi. When Wi-Fi was created about 20 years ago, it originally started in the 2.4 gigahertz band. That's that small band all the way on the left here. That quickly got congested, and then they opened up the 5 gigahertz band for Wi-Fi. Then tons and tons of applications came up, and then it's an explosion of use cases. And that's led to great benefits for society, and we all use Wi-Fi every day. But what happens now is that 5 gigahertz band is getting congested. Fortunately, what the FCC is doing in the US is it's opening up the 6 gigahertz band for Wi-Fi. And over there, we have about 1,200 megahertz of spectrum, which is going to be open for unlicensed. This can lead to a huge new set of applications, wireless applications. So it's really exciting. Now that's unlicensed. What unlicensed means is that anybody could transmit there as long as they transmit at low power and as long as they play fairly with the other devices which are out there. Now, there's some circumstances, though, such as if you run a manufacturing plant, where you don't want anybody else to be transmitting there. In that case, you want to be the only person transmitting in order to ensure a reliable network and a safe network. So for that, you want license operation. In a licensed band, this is what, for example, the mobile carriers do, the AT&Ts, the Vodafone, so forth. They license spectrum, and they sell it to customers. However, that's often difficult to get because you license spectrum on a large geographical area, a state or country size. And if you run a manufacturing plant, you only want it in your building. But another major innovation on the spectrum side was done a few years ago by the FCC, where they opened the CBRS band for doing locally licensed, which means that a manufacturing plant can license the spectrum only within their building indoors, and within their building, they're the only people allowed to use it. So this can lead to a huge number of different opportunities. Now that was just one glimpse in what's happening with spectrum. Here's a little broader glimpse. What you see in the center here is a spectrum, and this is a US view, and it goes from 600 megahertz all the way to 100 gigahertz. I've shown it on a log scale so we can squish all that spectrum in there. What you see in blue is the licensed spectrum used today, and in orange is the unlicensed. The key point I want to leave you with is over the next 3 years, there's going to be a humongous amount of additional spectrum being made available, and this can open up tons and tons of opportunities. Okay, you don't just want spectrum. You want to be able to get on that spectrum and use it. I mean, we all use these wireless devices, and one problem which probably all of you have had is getting on a wireless network. Now, why is this complicated? What usually happens is when you go to a new venue, like an airport, they ask for what your name is, what your email address is, and to sign some terms and conditions, and then they let you on, okay? With cellular, you don't have to do that, though. You can just seamlessly get on. And that's what we tried to achieve. Can we get for Wi-Fi the same sort of seamless onboarding as you have for cellular? My team started working on this about 3-4 years ago. We came up with a technology that's now being standardized by the Wireless Broadband Alliance, and it's being rolled out. And just 10 days ago, the Wireless Broadband Alliance also announced this new ecosystem to make the equivalent of one federated global Wi-Fi network over the entire world. The idea with this is that if this succeeds, you can go anywhere within the world and be able to get on a Wi-Fi network as easily as you could do cellular today. At the bottom, you see the list of 31 initial companies who are part of this, and this list is growing quickly. So now what happens is on mobile devices, we have two modern, very powerful wireless technologies here, Wi-Fi 6 and 5G. And you're going to be using both of these in the future. And depending on where you are, what you're doing, your device will pick whichever is the best to use. Here's an example day. In the morning at home, you may start out with Wi-Fi. As you drive to work, you'll use 5G cellular. As you go to the office, Wi-Fi. As you walk to lunch, 5G, and so forth. And what happens is your device will determine which is the best one to use to maximize your application performance, to minimize your cost, so forth, and it'll just do that for you. Now, what are some use cases we can use this for? One of my favorite use cases is interactive multi-user augmented reality. I think this is going to be enormously beneficial for education, for solving various work tasks, as well as for entertainment. I'm not going to talk more about this here because it's covered in some other sessions. But let me talk about these two use cases. What you see on the left here is the case of a future venue, let's say a theater or another convention center or so forth. What the venue owners are trying to do is they want to provide every user with their own personalized augmented reality or virtual reality experience. That is, they want to provide personalized AR/VR experience to every single seat in the house. Okay, that can really transform what you can do at these events. Now, this is really challenging because this is a very high density environment. The density of devices here is much higher than you have at work or at home, and the megabits per square meter is also much higher than what you have at work or at home. So this is very challenging, but we believe we can solve it. On the right-hand side, you see IoT manufacturing. Now here you see a whole bunch of robots in orange. These robots are usually connected via wired networks in order to support the reliability and safety that's needed in these manufacturing plants. Now, as the manufacturers go to Industry 4.0, what they want to do is something called Agile Manufacturing. And in Agile Manufacturing, what they want to do is to be able to change what they build very easily throughout the day in order to adapt to the type of demand they have. So in that case, they want these robots to be able to move around, and they don't want them wired anymore. They want them to be wireless while still having the same reliability of the network as you'd have with a wired network. To make that possible in Germany, as well as in other countries in the world, they're beginning to open up different frequency bands for this. In Germany, they opened up the 3.7 gigahertz frequency band as an example of for locally licensed use. So this manufacturing plant indoors within its building can use the 3.7 gigahertz band, and it's the only one allowed to use those frequencies in the manufacturing plant. So this can open up quite a number of other opportunities. Let me talk about a couple examples now of smart building use cases. Here you see an example of a PoE-powered hotel. This is the Sinclair Hotel in Texas. It's a famous hotel. It's about 97 years old. And when they remodeled it recently, they basically changed how they would connect and operate the entire hotel. What they went to is something called Power over Ethernet, PoE. Now, Ethernet is something we're all familiar with. At work, this is the wired network you use as well as at home. And Power over Ethernet means that you don't just send data over the Ethernet, you also can send power. You can send 30 watts, 60 watts, or up to 90 watts. This is really powerful because devices like lights or phones or TVs or mini bars, you can just have a single cable there going, which provides data transmission, can turn the things on or off, and also can provide power. In the case of the hotel, they were able to converge from quite a number of separate networks into a smaller number of networks and require 30 to 40% less power. So this is an example of a smart connected building. Let me talk about another example here. This is for sensing our environment. In outdoors, we use these devices with GPS to determine our location and find directions. Unfortunately, GPS doesn't work indoors. However, indoors, we still want to be able to know our location, to know directions, to identify if rooms are occupied or not, to estimate people density for social distancing, to help with security, and also to guide robots for robotic motion. On the right-hand side here, I list a number of use cases, and I also show the accuracy required. So you can see the accuracy can vary quite a bit from one use case to another. So now how can we do this sensing? Let me mention 3 different approaches. The first is using video cameras with deep learning. And this approach can work very well. It can identify various objects in the scene, can count the number of people, so forth. But it's a very compute-intensive approach and also privacy issues because of the cameras. A second approach is using wireless APs in people's wireless devices. Now, for example, whenever this device transmits a packet, all the APs surrounding it may receive the packet, and they may use that received packet to triangulate to find the location of this device. That's what I'm showing you here on the right. Now, a third approach is what we would call RF sensing. This is a new approach, and it's very exciting. It's similar to radar. In radar, which we have in planes and boats and cars today, what happens is you transmit a signal, and you look at the reflected signal, and from the reflections, what you get back, you try to understand what's happening. Well, in an indoor environment, you have these devices and APs also transmitting signals. So you can have the APs also listening to see what comes back, and from that, put together, let's say, an RF image of the surrounding environment. This can be really useful because you can then identify, is there motion, how many different objects are moving, how big they are, how many people they are. And this has a number of advantages. For instance, it can provide improved privacy as compared to video cameras. And also, you don't need any devices. The individual doesn't have to have a device, and you can still identify that there's a human being over there. So this exciting new area There are a variety of different academic groups working on this, as well as startups and bigger companies. And I think there'll be some great results in the near future. So what I described to you is some emergent opportunities with wireless and AI for smart cities. And I look forward to talking about this more in the panel. So back to you, Emily.
Thanks, John. That was really interesting. We're quite short on time at the moment, so we'll have a short panel discussion of just under 10 minutes. So I thought I'd quickly start with, if I heard you right, mentioning seamless wireless connection, John. It's wonderful that people will be able to automatically get onto Wi-Fi in the future with automatically sharing their identity, but are there any sort of privacy issues around that?
Oh, great question. Awesome question. Now, normally today when you get on a Wi-Fi network, they ask you for your name and your address, so forth. So today you have to share that information. What happens is that the people who own the venues, they primarily want to ensure you get a great experience. And they are, in many cases, don't really need to know who you are. They just want to be able to track you down if you cause a crime. So what happens is there can be an extra level of, you could be anonymous while getting under. So for example, I'm a Cisco employee. If I go in a venue, I'm also an AT&T subscriber and have a Google account, so forth. I can use any of these. And when I go in a venue, all the venue needs to know is that I'm a Cisco employee. And if I do something bad, the venue could ask Cisco for who I am, and Cisco can provide that information if I cause a crime to the police. Otherwise, I can still be anonymous. So actually can provide more privacy than what we have today with Wi-Fi onboarding.
Okay, great. Thank you, John. And is it valuable only for people, or can it help IoT devices too, such as the devices that Heba and Dev mentioned?
Oh, that's excellent question. What happens is for IoT, we want to get all kinds of devices connected, and things like open roaming can help devices easily get connected. Also, today, cars are connected. And as you have a car, be it an electric car or gasoline-powered car, as you pull up to various venues, you may want it to automatically get connected at a gas station, at a service station, and so forth. And this can help you automatically get connected to. So it's also, once again, very useful for IoT. And specifically here, what you want is you want to ensure that only the right connections happen. And you describe the policy ahead of time, what those connections are.
Great, thank you. And to Heba and Deb, I think we've seen the rise of ESG before coronavirus, but I think it's clear that the importance of ESG and sustainable buildings, and as you mentioned, people-centric developments with a focus now on sort of mental and physical well-being are going to become more important. How do you see AI and machine learning contributing to the environmental and social impact of building, whether that's reducing wastage or what do you think?
Sorry, is this a question to me or to Dev, or do you want us both to answer?
Either, both.
Why don't you start, Heba?
Well, this is my first time as John as well to be in CogX, so this is a great opportunity to be part of it and to present for our system. Our system actually, the way of what we deal with it in terms of wastage and how can I actually mitigate certain aspects in a civil engineering. We've noticed that digitalization is imminent, especially in COVID, because the number of employees you can have on the site, it's definitely you have to minimize the number of people on the site. And the only way to enable you to do that is monitoring the site or having a wireless system. And if you're minimizing as well the number of people and measuring these aspects and checking that your building is standing, you are doing the displacement correctly, X, Y, and Z, peak-to-peak velocity, you are minimizing waste automatically because people aren't there. They are, of course, it's having people there are creating waste all the time. In terms of management for it, we don't deal with that because that is something probably nPlan would do and will mitigate within the structure of their mapping the project. So I will pass that to Dev.
Yeah, quite simply, waste is when you are unable to plan properly, yeah, and you have resources that are being applied in an incorrect manner. Now, that builds perfectly on what John and Heba were talking about, where you use wireless networks and sensing as well to ensure that you have the correct allocation of resources. In nPlan's specific case, it's the resource of time, which is you want to plan things and you have to time sequence things correctly. You could imagine if I tell you it's going to take 10 days to paint a wall, and then you're the electrician that's supposed to come after 10 days, and actually it's going to take me 20 days, then technically I've created 10 days of waste because you're the electrician that now has to wait for 10 days to do your work. That, by the way, is a very common thing, right? Whether you're doing your house or you're building Crossrail, these sorts of problems happen at every scale. And machine learning is essentially this technology that helps you think about the complexity that we don't like thinking about. We're not great at doing these sorts of calculations in our mind, and being able to leverage the best of sensing as well to make these decisions is always a less wasteful outcome.
Thank you, Heba, and thank you, Dev. Another question for Heba. You also mentioned getting people back to work safely through the use of AI. And I think the way people commute and transport preferences are going to shift, and where possible for more people cycling, walking or driving after COVID and because of social distance. And how do you think AI can help big cities accommodate this shift in sort of a relatively short space of time?
I think one thing's probably COVID, it make us realize we do have, as a human being, different resources, and we need to utilize these. So I would talk about Utterberry's employee. Everybody now works from home, and we were focused mainly in our office in central London. Of course, it's not good for communication, but instead of using the underground, we are using other facilities, which is cycling, walking. They are utilizing even within the company. How can we actually work more efficiently without coming at the same time? So we're trying to mitigate, not coming all of us from 9 till 5. How can we actually have kind of a flexible working hours to work within the team, and utilizing that with the projects that we are doing in a way that will help us? And I think AI and machine learning, just to learn on the habits what we are doing now, which is different, it did bring in a different shock to our system as a whole. I would call it a big experiment. My favorite one probably what Sweden did, which was the only country probably in Europe that they didn't actually do enforced lockdown. And what we've learned, what we are going to learn, and probably the studies that comes out of this, it's a huge for the academic institution of learning. How can we utilize this? What can we do better to enhance? But one things we did see spike using of Wi-Fi network. It's been increasing digitalization. So the companies that didn't use digital is definitely affected them really badly, because if they don't have the resources of supporting the digital age, it's definitely affect companies and small businesses. But companies start thinking in a different way, even pubs and shops and the way they are doing things. I think it's definitely AI and machine learning. It will be a part of having to think in the next 10 years, because if we had this pandemic now, probably we're going to have something different later on, and how can we deal with it? And we just need to be more prepared.
Thank you very much, Heba. That brings us to the end of our session. Thank you very much to John, Dev, and Heba, and to CogX for hosting us.
Want access to more CogX videos? Subscribe now for free at cogx.co.